Welcome, students. So this is going to be my second video on the paragraph question. And this time we will discuss something about biochemistry related with the enzyme kinetics. Because I believe in the biochemistry, the enzyme kinetics is the topic which is given so much in the students. Now, let's read the paragraph question. And I think this is a paragraph question. Yeah. So it is about the phenylalanine hydroxylase, which is an enzyme. And in the paragraph, it is given that it is a rate limiting enzyme of the phenylalanine metabolic pathway, right? Rate limiting means the slowest step. So phenylalanine hydroxylase catalyzes the hydroxylation of the aromatic ring of phenylalanine converted to tyrosine. Is this reaction we are talking about? And we are very much clear with the structures of the amino acid. The phenylalanine and the tyrosine, they are very similar. The nature contains average group, right, at the para position. Okay. Now let's read what is given next in this question. That phenylketonuria, now it's a disease they are talking about, which is an autosomal recessive genetic disorder that results from an inactivated mutation in the gene coding for PAH, right? Means this is a particular enzyme. This particular enzyme must be coded by a gene for the PAH, and in that particular gene, there's a mutation, right? Now, the most common of which replaces cytosine with adenine at position 742, right? So it sounds like a point mutation, right? If I write in the side, it sounds like point mutation because you are going to change a single amino acid from one to the other, right? Okay. Now, an alternate form of the phenylketonuria results from a deficiency in a cofactor tetrahydrobiopterin. Now, the point is that what are cofactors? It is for the students who do not know about it. So biochemistry says that when an enzyme is not able to work on its own, that is known as apoenzyme, right? Apoenzyme. And that apoenzyme means, of course, the protein portion of the enzyme. It is protein portion of the enzyme, but inactive version of the enzyme because it is not able to work on its own. Why? Because it needs something like a colleague or a cofactor to help, right? And then it becomes whole enzyme, right? So the question is saying that the enzyme for the enzyme for this particular reaction, the PAH, requires a cofactor naming tetrahydrobacterin for its function. So definitely, if you are low in cofactor or if you do not provide cofactor to your enzyme, it will not work. Simple. Now, so those with PKV are unable to metabolize phenylalanine and convert it to tyrosine, resulting in a buildup of phenylalanine. Means so far they have given only two ways in which the enzyme of the PAH is not going to work. First is they have given the point mutation. Second, they have given absence of cofactor, right? Absence of cofactor. In both ways, the enzyme will not work, and definitely your substrate concentration will go, right? Now, excess phenylalanine is then metabolized to form phenylpyruvate via the action of the enzyme phenylalanine transaminase, right? And for that part, they have not given any equation, so we can better draw. Please, if you build up this in the absence of this, the reaction will take go into another direction, in which it will form phenylpyruvate, right? Phenylpyruvate by the basic enzyme phenylalanine transaminase, or we can name it, right? Now, without enzymes to remove phenylalanine, this amino acid can build up to a dangerous levels. The point is that if your pH is not working, your phenylalanine can take another route and convert into phenylpyruvate if you have another working enzyme, that is phenylalanine transaminase. But if this is also not working, then definitely no one can help you in decreasing the concentration of the phenylalanine, or basically you will increase the concentration of phenylalanine. So especially when the foods is consumed, which is in high protein, such as meat, milk, nuts, and cheese, right? So these foods need to be avoided if you are deficient in this enzyme or both of the enzymes. Okay. Now, the first question is about how would you expect the mutation associated with the behavior to affect the catalytic efficiency of the phenylalanine transaminase? They're talking about PAT and not the PAH, right? Now, how would you expect the mutation associated with PKU to affect the catalytic efficiency of the phenylalanine transferase? So, phenylalanine transferase being an enzyme or a protein, there are many four options here, right? Like KCAT will decrease, K will increase, and will decrease catalytic efficiency, and KCAT. So, because in all the options contain K and KCAT, so I'm going to explain you the meaning of the KCAT in here in just my own simple words. But KCAT means how good your enzyme is doing its job, isn't it? Because we know that there's a equation between the KCAT and Vmax input, right? And Ka is the how much enzyme likes its substrate, or high affinity of the enzyme means low K. Everybody who is preparing for the MCAT should be clear about these terms, these terminologies, right? Okay, so Kcat means how good your enzyme is doing its job. Km means how much the enzyme likes its substrate, or basically if the enzyme is having a Km, that means that, right? Okay, now the Kcat will decrease and Km will increase, able to decrease catalytic efficiency. The question is about how would you expect the mutation associated with PKU to affect the catalytic efficiency of the phenylalanine transferase. So if I go back to the question right here, they are talking about the point mutation in the PAH and not the point mutation in the PAT, right? So this option seems incorrect. Next. KCAT will increase and Km will decrease, leading to an increased catalytic efficiency. Will this? Well, I don't think so, because the point is that the KCAT and Km will not change, leading to an unchanged catalytic efficiency, because they both are the intrinsic property of the enzyme. Recall that. Some of the students might ask that we have seen the change in the value of the Km and the Vmax when there's a talk about the inhibition, right? Like the competitive inhibition, non-competitive inhibition, mixed inhibition, uncompetitive inhibition, right? Now the point is that there's not only inhibitor they are talking about. There's no inhibitor. There's nothing which will come and go to bind to the allosteric side. There's a talk about the inhibitor in this question, right? So basically, by changing by changing a gene in PAH will not going to affect in the PAT. This is the first thing. Other thing is that these two are the intrinsic property of the enzyme, and so they will remain changed, right? So this question we can answer only if you have gone through the entire KCAT in the KM and the Vmax understanding into the enzyme dynamic section, which my students know, right? And that's why they are scoring like above 5.0 in the MCAT exam. And for the AP, we are getting like 4 on 5 and 5 on 5. So it gives me a large amount of points, right? Also, those people who do not know the relation between the KM and the KCAT, there is one equation, which is going to KM is equal to the rate of forward reaction plus KCAT over rate of, KR means for the reverse reaction, KF means the converted reaction, right?